Welcome to Pre-AMC Week 7, Problem 1. There are 4 points A, B, C, D on the coordinate plane. So what is the area of rectangle A, B, C, D? So, okay, so we have A, 1, 1. A, B, 1, 4. X equals 1, Y equals 4. B, C, 3, 1. And D, 3, 4. So that's rectangle ABCD. So let's calculate the length of AB because that is the length of the rectangle. Okay, so because from A to B is a vertical line and they have the same x coordinate 1 and a different y coordinate which is 1 and 4. So then between A and 4, A and B, we just need to calculate how many units here, this line. So 1, 2, 3 units. Okay. Also, we can figure out the length of the AC because A and C, they will have same y coordinates, which is 1, and they have different x coordinates, which is 1 and 3 respectively. So the AC is actually a horizontal line. So the length of the AC is just the horizontal, the x coordinate, subtract 6x coordinate, subtract a coordinate. Actually, we can count it here too. So 1, 2. So the area equals 3 times 2. So equals 6. Okay, the answer is 6. Problem 2. In triangle ABC, AX equals to XY equals to YB equals to BC. So the angle BAC equal to 15 degrees. So what is BCA? Okay, so let's look at this triangle AXY. So because AX equals to XY, so triangle AXY is an isosceles triangle. So these two base angles XAY and XYA should be equal to each other. So then XYA is also equal to 15 degrees. So this angle AXY, so we know the sum of the 3 interior angles in triangle equal to 180 degrees. So that we use at 180 degrees, subtract 15 to 15 degrees. So subtract 30 degrees. So this one is 150 degrees. Okay, so angle AXY and YXB, so if they are actually linear pairs, so they are supplementary to each other. So then 180 degrees, we can use 180 degrees, subtract 150 degrees, that is 30 degrees. Okay, so then let's look at the triangle XYB. So because XY equals to YB, that is also isosceles triangle. So we have a base angle YXB and the angle XBY should be equal to each other. So that's the 30 degrees. By same way, so we use 180 degrees, subtract 230 degrees. So this is a 120 degrees. Okay, so by linear pair, so 15 degrees plus 120 degrees plus angle BYC should equal to 180 degrees. So that is a 45 degrees. Okay. So then finally, let's look at the angle BYC. So because BY equals to BC, they are isosceles triangle. So then we have the base cell or base angle is equal to each other. So we have 45 degrees. Okay, 45 degrees. So finally, we have the answer BCA equal to 45 degrees. 45 degrees, and the answer is B. Problem 3. If m and n are positive integers such that m squared plus n squared equals to 80, what is m plus n? So we have equation m squared plus n squared equals to 80, and m squared because m squared is a positive integer, so it will be greater than 0, not equal to 0. So m squared for all the real number is equal to 0, but the m here is a positive integer, so m squared is greater than 0. Okay, so n squared greater than 0. Okay, so then we will have m squared should be less than 80, n squared also less than 80. So then we have two perfect squares. The sum is 80. And we can list all the perfect squares from between 1 to 80. Okay, so 1, 4, 9, 16, 4 squares, right? 4 squares, 25, 36, 64, 49, 64. And the 81 won't be included because the 81 is larger than 80. Okay, so then we would have, see which two numbers added up to 80. So it's 60 and 64, right? So 16 plus 64 equals to 80. So that would be 4 squared plus 8 squared equals to 80. So m or n could be equals to 4, n equals to 8. So m plus n should be equals to 4 plus 8 equals to 12. So the answer is B, 12. Problem 4. A company is building a road. According to the original plan, works will build 60 meters per day. In fact, they have built 4 meters more every day and have finished the project 3 days before the scheduled time. So what is the total length of the road in meters? Okay. So let's say they use n days to finish the project actually. Okay, so they actually build 60 meters and 4 more meters more every day. So 60 plus 4, 64 meters every day. Okay, the original plan is 60 meters every day, but they build 4 meters more every day, so 64. So the total length of the road, so we have 60 meters every day, so we build n days is 6 times n, and it should be equal to, according to the original plan, so they build 60 days, or 6 meters every day, and you have 3 more days, so n plus 3, so times n plus 3. That is the total length according to the original plan. So that should be equal to each other, total length, right? So then we just need to solve for n. So 180 and equals 45. Okay, so we actually have 45 days to finish the project actually. Okay, so then we have total length, it's 64 multiplied by 45. So we will have 4 times 45, 64, 2,880. Okay, which is D. Problem 5. 2 of the following 4 facts about a positive integer n are true and 2 are false. So what is the value of n? So we have 4 statements. Okay, so we can see actually statement 2 and 3 is contradicted to statement 4. So because if n is less than 10, it won't be divisible by 11. And it won't be divisible by 55. If n is divisible by 11 or 55, it won't be less than 10. So then we have to group 2 or 3 together and 1 under 4 together. Okay, so then we have 2 possibilities. So we can have false, true, true, false. So 2 and 3 are true, 1 and 4 are false. Or we can have true, false, false, true. and 1 and 4 are true, and 2 and 3 are false. Okay, so let's look at this possibility. Okay, so n is divisible by 5 is false, and n is less than 10 is true. It's a false too. It's a false. But the n is divisible by 11 is true. N is divisible by 5 is true. So that could not be possible because the n is divisible by 5, 55, also divisible by 5. So that is not right. Okay, so this one doesn't work. Okay, so doesn't work. So then let's look at this possibility. So n is divisible by 5 is true, and n is less than 10 is true, and n is divisible by 11, and n is divisible by 55 is false. And this did work. Okay, so it will be 5, right? The n equals 5. Okay, so what is the value of the n? It's a 5 then. Problem 6. A square-shaped floor is covered with congruent square tiles. If the total number of tiles that lie on 2 diagonals is 9, so 2 diagonals, how many tiles cover the floor? Okay, let's draw this diagram. Okay, so we have this 2 diagonal. So the total number of tiles lies on the 2 diagonal is 9. So we have 1 tile has to be in the middle, shared by these 2 diagonals. So then we have 8, 9 minus 1, we have 8 tiles, okay, left. So 8 tiles would be on 4 of these diagonals. So 8 divided by 2, or by 4, equals 2. So there should be 2 tiles laid like this. Okay, to each diagonal. Okay. Okay, so that's our floor. Okay, so let's count how many rows and how many columns. So 1, 2, 3, 4, 5. 5 rows and 5 columns. So total tiles number is 5 times 5, 25. Okay, so 25 tiles cover the floor. So it's the E. Problem 7. What is the area of shaded region in the following 7 times 7 grid? Okay, so let's look at this shaded region. Okay, so we have an octagon here, and it's easy, actually easy for us to calculate the area of this octagon. We just need to count how many small squares and how many half small squares, right? Okay, so then if we try to calculate the area for this type of triangle, which is not hard to, because basically that is a half of that rectangle, which area is 2, so half it is 1. But finally, let's try to calculate the area of this type of triangle. So we have a base, actually, which is diagonal, it's not 1. And if we try to draw the height, okay, so it's a little bit difficult to calculate the length of the height. So, okay, so it is a little bit difficult to calculate area for this type of triangles. So then we need to think maybe there is another easy way to count it, to calculate the area of the shaded region. So we actually can use a complementary way. So we can use total area, subtract shaded, unshaded area. So shaded area equals total area, subtract unshaded area. Okay, because when we try to, okay, So when we look at the unshaded area, so we can have some triangles like this, and that is easy to, actually that is easy to know the area is a 1, right? So we just look at, we just need to look at this rectangle here, and the rectangle has a length 2 and the width 1, so the rectangle area is 2, and this triangle is a half of the rectangle, so it's a 1. Okay, so this type of triangle is a 1. 1. Okay. Okay. So, okay. So we have 1, 1, 1, 1. So then what we have here is all rectangles, right? So let's connect these dots to form rectangles. So it's easy to calculate rectangle area, right? It's 3 times 1, 3, 2 times 1, 2, 3, 2, 3, 2, 3, 2. So we just need to add all these areas. That's the unshaded area. Okay. So total area equals to 7 times 7. And unshaded area equals to 6, 7, 8, 9, 10, 11, 12. Okay, 12, 1 plus 4, 2 and 4, 3. Okay, so that's equals 12 plus 8 plus 12, 32. Okay, so then we just need to subtract 32, 49, subtract 32 equals to 17. So the answer is D, 17.